Bismillahirrahmanirrahim. New syllabus 6 SSC1 Unit number 6 Work and Energy. Exercise 6 Numerical Problems Unit number 6 6.6 to 6.10. We will discuss in previous video 6.1 to 6.5. Now we will discuss 6.6 to 6.10. Question number 6. A motorboat moves at a steady speed of 4 meters per second. Water resistance acting on it is 4000 Newton. Calculate the power of engine. Given data, speed is equal to V is equal to 4 meters per second. And water resistance. Water resistance is equal to force and F is equal to 4000 Newton. To find power, so we know that power P is equal to work upon time. Here we can given data speed and force. So we can convert this formula in power, force and velocity. So power is equal to work upon time and W is equal to Fs. Putting this value in equation, power P is equal to Fs upon T. We also know that S is equal to Vt, then V is equal to S upon T. Then V is equal to S upon T, putting here. Then power P is equal to Fv. Now final formula P power is equal to force multiplied by speed. In solution, putting the value of force and speed, then P is equal to 4000 multiplied by 4 is equal to 16,000 watt, or power is equal to 16 multiplied by 1000, and 1000 is equal to kilo. So the final answer of power P is equal to 16 kilowatt. Result, power of engine of motorboat is 16 kilowatt. Now, in question number 7, a man pull a block with a force of 300 Newton through a 50 meter in 60 seconds. Find the power using by him. First of all, we write the given data. Force F is equal to 300 Newton and height is equal to its distance S is equal to 50 meter. Time taken, time T is equal to 60 seconds. We can calculate the power. So to find power P, write the formula P is equal to work upon time. And we know that work is equal to force multiplied by distance S. Then Fs upon T. Putting the values, power P is equal to 300 multiplied by 50 divided by 60 is equal to 25 watt. Now the power used to pull the block is 250 Newton. Question number 8. In question number 8, a 50 kilogram man moved 25 steps in 20 seconds. Find the power if each step height is 16 centimeter high. Now write the given data. Given that mass of man M is equal to 50 kg. Number of steps denoted by small n is equal to 25. Height of each step is 16 centimeter. Now total height h is equal to number of steps 25 multiplied by height of each step 16. 25 multiplied by 16 is equal to 400 centimeter. 400 centimeter convert into meter divided by 100. So 400 divided by 100 is equal to 4 meter and time t is equal to 20 seconds. Now gravitational acceleration small g is equal to 10 meter per second square. To find power P, we write that formula P is equal to work upon time. We know that work done is equal to potential energy and potential energy is equal to mgh. Putting this value, so power is equal to mgh upon t. Solution, putting the values P is equal to value of M is 50 multiplied by value of G 10 and height 4. 50 multiplied by 10 multiplied by 4 divided by time 20. The final answer is 100 watt. So the result, the power of is a body 400 watt. Now, in question number 9, calculate the power of a pump which left 200 kg of water through a height of 6 meter in 10 seconds. Now, we can write the given data. Here, mass m is equal to 200 kg, height h is equal to 6 meter. Time t is equal to 10 seconds and gravitational acceleration small g is 10 meter per second square. Now to find power, power is equal to P. Then power P is equal to work upon time. We know that work is equal to potential energy is equal to mgh. Putting this value here, then P is equal to mgh upon T. Solution, P is equal to mgh upon T. The value of m is 200 multiplied by 10 multiplied by height 6 divided by time t. T is 10 seconds. So 200 multiplied by 10 multiplied by 6 divided by 10 is equal to 1200 watt. So the power of pump is 1200 watt. Question number 10. An electric motor of 1 horsepower. Here power is 1 horsepower. Is used to run the water pump. The water pump takes 10 minutes to fill. Then tank has a capacity of 800 liters, height of 15 meters. Find the actual work done by the electric motor and also find the efficiency of system. Here, density of water is equal to 1000 kilogram per meter cube and mass 1 liter is equal to 1 kg. So, first of all, write the given data. Power P is equal to 1 horsepower and 1 horsepower is equal to 746 watt. Now, time t is equal to 10 minutes. Now convert into second. So 10 multiplied by 60 is equal to 600 seconds. Volume, volume V is equal to 800 liters. So mass M is equal to M is equal to 800 kg. Similarly, 1 liter is equal to 1 kg and height h is equal to 15 meter. Now write to find the work W is equal to question mark and efficiency E is equal to question mark. Here we can use the formula P is equal to power is equal to work upon time. We can find input is equal to work done. So calculate here P is equal to W upon T. Here T is divided and other side it will be multiplied. Then work W is equal to PT. Output potential energy at a maximum height. So potential energy mgh. Now last find the efficiency. Efficiency is equal to output divided by input. Now firstly find the input. Work is equal to P multiplied by T. Power multiplied by time. Then W is equal to 746 multiplied by 600 is equal to 447600 joule. Then we can calculate the value of work done as the input 447600 joule. Then we can calculate the output as potential energy, so is equal to mgh. Putting the values 800 multiplied by 10 multiplied by 15 is equal to 12 tetra zero joule. Now we can find the efficiency is equal to 12 tetra zero divided by 447600 is equal to 0.268 as the efficiency. Now we calculate the percentage, then multiply by 100, so is equal to 26.8%. Thank you. Best of luck. Inshallah in next lesson with length.